All right, so we're going to talk about our earliest hominid ancestors, and for the one cast that we have at the college is from our earliest purported hominid ancestor, which is called Sahelanthropus chadensis. Hopefully you've read about it already. This is dates to between 6 and 7 million years ago. It was found in along the MYA millions of years ago. It was found along the banks of Lake Chad in more sort of West Africa. So not only is it unique because it's so old compared to the majority of other fossils that we found so far, but it's also unique because of where it was found. Again, the majority of our fossil finds are from the east part of Africa and the south part of Africa. But at the beginning part of the century, when the team found this fossil, they had only been searching in these different parts of Africa for only a couple of years. Okay, so the question that is asked with our earliest hominid ancestors is, how do we know that this is one of our ancestors versus ancestor of a chimpanzee or a bonobo? And so there are the main difference is going to be bipedality versus quadrupedalism, right? Walking on 2 legs versus 4 legs. And on a skull, there's very limited features to be able to tell if an animal walked on 2 legs versus 4. So we'll talk about that in a moment. The other characteristic is a decrease in the canine size, and that decrease is called a non-honing canine. So what this means, I'll bring out the gorilla skull again, is that in animals that have a really large canine, when the animal opens and closes its mouth, the canines will rub together and they will actually wear away a portion of the canine. And that wearing away or sharpening or honing can be used by the animal. Actually, the gorilla can use these sharpened edges of its canines to cut grasses, for example, when it's eating. Well, with that decrease in canine size, then there's not going to be honing. So one of the things that we can pay attention to is the decrease in canine size. And indeed, Sahelanthropus chadensis has smaller canines than what modern day chimpanzees and bonobos do. So the hypothesis is that it's going to be more associated with our line, and this is this decrease in canine size is associated with us having quite small canines. So I talked about bipedalism as a characteristic of hominids, and so I'll continue with this. The one characteristic that we pay attention to on the skull that's associated with bipedalism is the location of the foramen magnum. So the foramen magnum is the big hole, and in fact that's what foramen magnum means in Latin, is big hole. Foramen is hole, magnum big. And the location. In bipeds, the foramen magnum is more centered or on the underside of the skull. In quadrupeds, the foramen magnum is going to be more toward the back of the skull. So to use a modern human and a modern gorilla as examples, you will see, hopefully, that the location of the foramen magnum is more tucked under in a modern human, and in a gorilla, it's further back. And in an animal like a deer or a dog or something that's truly quadrupedal, the foramen magnum would be even further back on the skull. So in Sahelanthropus chadensis, the foramen magnum is tucked underneath more than what you would expect for the kind of quadruped that a gorilla or a chimpanzee is. Okay, and then this third topic to bring up has to do with brain size. So when we talk about hominids, one of the characteristics that we're going to talk about is increased brain size for its body size. For a long time, for literally millions of years in our hominid ancestors, these animals were relatively small, kind of chimpanzee size. You see the difference in skull size between Sahelanthropus chadensis and a modern human. There's a big difference in size. And this size stays relatively consistent for millions of years. Come over here and give a couple of examples for other animals. So here is Sahelanthropus chadensis, and here is a gracile Australopithecine that's from millions of years later, 3 to 4 million years later. There is a difference, right? There is a difference in brain size, of course, but not dramatic. The difference, and then this other cast here that I will talk about later, is Homo habilis. And so again, still relatively small animals, but again, there is a big difference in brain size. So what we are paying attention to as we move into the hominid line is these two topics in regard to our brains. One is the brain size to body size ratio. So when I talk about primates, I talk about that in general. We have a big brain compared to our body size. And this is true, of course, with Sahelanthropus chadensis. We are clever compared to what you would expect. With the hominid line, you're going to see eventually an increase to how much brain we have compared to how much face we have. And so with Sahelanthropus chadensis as the first hominid in our line, there is a lot of face and, for example, not much forehead. And so this will be a general trend that we will see going through our line of hominid ancestors, is with time you will see an increase in brain size. That's called encephalization, right? So the brain size will increase, and with that will be a larger sort of brain case in comparison to how much face there is in that individual.